right, the next subject here is multiple cash flows. So right here you have a series of cash flows that is not at the same amount. So consider investment that pays $200 one year from now, that's in year one, and then the cash flow would increase by $200 through year four. If the interest rate is 12%, what is the net present value of this stream of cash flows? So you are going to use the NPV function. Net present value is NPV. It stands for the summation of the present values of all cash flows. So if it's net, basically it combines both positive and negative, just like a net fixed assets, right? You have a total assets minus cumulative depreciation. So net conveys the idea of positive, negative together. The present value, that indicates you're going to convert each of the future cash flow into a present value, and then of course you're going to sum them up. In this particular case, that's the cash flow you see. So in the first year, you're going to get 200, second year, 400, third year, 600, and then 800 in the fourth year. So you want to know the present value of each. So you're going to discount each of the future value. 200 discounted by 1 year with a 12% rate, it will be a 178. 400 discounted by 2 years, okay, with 12% rate, discounted for 2 years, that's a $318. And then 600 discount, 800 discounted. And then you're gonna add all up to get this net present value, that's a 1432. You do not have a negative number. If you have a negative number, so just one of the present value would be negative. All right, so how do you use NPV function to solve for it? So you gotta lay out all the cash flows in your calculator. So you gotta put a cash flow 0 all the way to cash flow 4, and the interest rate will be set as a 12. That's 12%. The thing is, although there's no money being received here or spent here, you still need a valid number for cash flow 0. So for the time being, we just leave it 0. So you do need a number 0 here for cash flow 0 in order to carry out the calculation for NPV. And then your NPV output will be 1433. In your Excel, it's actually pretty simple. Once you have all the cash flows layout and then your interest rate is 12%, you use 0.12 for 12%. Do not use 12. Otherwise, Excel would recognize it as 1200%. And then you use the NPV function. So it's NPV, then the first thing you put will be the interest rate, comma, and all the cash flows included. Well, you will see that in the NPV parentheses, the cash flow, the first one is a cash flow 1. It's not actually cash flow 0. So if you have a valid number for cash flow 0, you just add it outside the NPV function. For example, if your cash flow 0, if I put here as a negative 100, just to make NPV minus 100. For capital budgeting cases, it's more like today you deposit a certain amount of cash and then you expect to receive cash in the future, right? If that's the case, you're going to have a negative cash flow in your series of present values. The next topic here is compounding periods. And right here, compounding basically means you accumulate the interest, you raise to the power, take the exponent, so to solve for the future value. The future value here is cash flow 0 times 1 plus interest raised to the power of a t number of years. And if you invest $50 for 3 years at a 12% rate, which is, this is compounded annually, you're going to raise the annual rate by the number of years to get the future value. So that's something we have learned before. This will be fairly simple. However, in some other cases, your compounding basis is not annual. It could be monthly, it could be semi-quarterly, could be semi-annually, could be quarterly. So you have to incorporate that compounding frequency, which is the m times the year. And m would be 2 if it's a semi-annual compounding, semi means half. M would be 4 if it is quarterly compounding, and M would be 12 if it is a monthly compounding. So what you do here is you're gonna calculate each period, let's say each month or each 60. Let's say if it's a semi-annual compounding, then you're gonna cash out your deposit after 6 month period and then reinvest that principal and interest again to get more interest. So you're gonna do that not on an annual basis, not every year. You're gonna do it on a semi-annual basis. If that's the case, you would end up with a different future value for the ending balance. So if you use R as a 12%, still is the annual rate, and M is a 2, so you're gonna divide 12% annual rate by 2 to get a 6% semi-annual rate. And then when you do the compounding, how many times you're gonna do this reinvestment? You're gonna do it not 3 times, not from these 3 years. You're gonna do it 6 times. It's actually M2 times 3 years, so that's 6. If you put in a calculation, so 12% divided by 2 to get a 6% semi-annual rate or 6 month rate, and then you're gonna compound it by the exponent, which is 2 times 3. 2 is the frequency, and 3 is the number of years, and that's going to give you 6. And you will see your future value is different than what you had previously. Your future value actually gets raised up higher. So here it comes to the effective annual rate. So if you want to know what your ending balance truly will be, you want to go with the effective rate other than the stated quoted rate. So this R in your formula is the quoted stated rate, which basically is directly provided by the bank to give you a basic idea of the annual rate. However, in order to figure out your ending balance, you have to go with the effective rate. And how do you calculate this effective rate? You need to divide the quoted rate by the frequency and then plus 1 raised to the power of m and then minus 1. So for example, if you have a 12% quoted rate, you're going to divide that by 2 and then plus 1 raised to the power of 2 minus 1, then the 12% rate would be as a 12.36%. Okay, so this would give you a 12.36%. So it's just like you invest your money and get a 12.36% each year for 3 years. So that's your future balance, okay, of $70.93. Okay, so you start with $50. If you invest at a 12% rate, compounded semi-annually, okay, so the fact that it's 12% compounded semi-annually is just as you invest at a 12.36% the effective rate and a compounded annually. All right, so the present value times 1 plus the effective annual rate raised to the power of number of year would give you the future value. So once again, if you are looking to borrow a loan or lend a loan, you will go for the effective rate to get the actual future value, the actual cash balance you have at the end. All right, to calculate the effective annual rate at a quarterly, monthly, or daily level, so here are the formulas. So you just replace M to number of 4 for quarterly, 12 for monthly, and 365 for daily. And if you raise the frequency, let's say annual, the frequency is 1, semi-annual, the frequency is 2, quarterly, that's 4, bi-monthly, that's a 6, so you have a 6 bi-month period in a year. Monthly is 12, and then weekly, bi-weekly, and daily, so on and so forth. So if you have $1,000 and you will have a stated rate of 10%. If it is compounded annually, so the ending balance will be $1,100, right? It's 1,000 times 1 plus 10%. But if you increase your compounding frequency from 1 to 2 to 4 to 365, your future value will keep increasing to a higher and higher number. So the bottom line is when the compounding frequency increase, you will end up with more future value given the same present value and the same stated rate. The next subject is called a perpetuity. So what does perpetuity stand for? Forever. All right, so let's say you have a constant stream of cash flows that last forever. So you keep receiving the same cash flow forever, not just for 1 year or 2 years, but for 10 years, 100 years, a million years, and forever till infinity. That's called a perpetuity. If you want to know the value of the stream of cash flows, it's not really infinite, although you have an infinite amount of cash flows put it together, but the total value of these cash flows would be limited. So the bottom line here is you're gonna discount each of the cash flow with the interest rate according to their period. This is the first period, second period, third period, and eventually the cash flows in the future would be reduced to zero present value. So you have the same same cash flow, but because your denominator getting infinitely large, then the present value of that cash flow would be zeros. So if you just add more future cash flows at present value, you just add more zeros. So it does not change your total values. Therefore, your present value has a limited number. Thanks to the mathematicians, we have this easy, crisp formula to calculate present value for the cash flows. You just use the cash flow divided by R. Okay, it's that easy. The thing is, some people still make mistake. Let's say R could be 10%. So do you divide it by 10%, right? So is that divided by 10 or divided by 0.1? So if you divide it by 10, then that's wrong. You have to divide it by 10% or 0.1. So 0.1 is the form of a 10%, and then you will get the value for the cash flows. So here is an interesting example. What is the value of a British council that promised to pay £15 each year, every year until the sun turns into a red giant and burns the planet to a crisp? The interest rate is 10%. Okay. So you see, there's unlimited years until the planet gets burned. So we will assume it's a perpetuity problem, and we will receive £15 each year forever, and the interest rate is 10%. So what's the value of this financial instrument? So you're gonna use 15 divided by 10%, so that is going to be 150.